Hello, stat students. We're about to get started in the second semester, and we're beginning things off with a review of what we finished up with last quarter, which is going to be random variables. So we're going to be looking at chapter 6, section 1, and section 2 today. And we introduced what a random variable was and how it relates to probability, and then we also talked about transforming them. So this is going to be our review. There's also an assignment that's going out with this, just to make sure that we get back into the flow of things. Make sure that you get that done. I'll have that up on Kitum. So let's go ahead and get started with this review. Okay. So let's go ahead and start with. I'm going to look at this. This is the review exercises that I'm going to have you guys do. If you have questions, reach out to me about these. These are meant to be challenging. These aren't multiple choice. You're meant to think through these. And what I'm going to be doing is I'm going to be working problems on this video that will correspond to these. Okay, so just be prepared to, if you need to go back and watch this video, you can either watch it on my YouTube, or I think Play Pause, it'll allow you to rewatch things. That's fine. But you're using this as your example to help you work these problems, this video. So we're going to begin with sort of a basic example. This is the objective here was to compute probabilities using the probability distribution of a discrete random variable. So remember, random variables have to be numbers. Okay, so any value that is a number, and we see that here, value, and then its probability distribution has the value that goes with it, and this is the probabilities that are associated with those. Okay, so it says spell checking software catches, quote, non-word errors which result in a string of letters that is not a word, as when the word "the" is typed as TEH. When undergraduates were asked to write a 250-word essay without spell checking, the number X of non-word errors has the following distribution. So they made errors in their writing. Okay. So it says write the event at least one non-word error in terms of X. What is the probability of this event? So I'm going to use a text box here, and so on your worksheet you can just write this down. We would say that at least one non-word error. Well, here's 1, 2, 3, 4. So we want X to be greater than or equal to. I think I can put in a symbol. I'm going to put it in this way. It's sort of the math type way. Greater than or equal to, we would say 1. Okay. Now it says what is the probability of this event? So I'm going to put a colon. We want probability that X is greater than or equal to 1. By the way, just to give you a sense of how I would actually be drawing this, it's X greater than or equal to 1. Okay, so now we want to find the probability of that. Well, what is that? Well, we take this, and this, add them all up, and we get 0.9. So that should be our answer to this problem. Okay, should be the answer to this problem. So we look at the second part. Hopefully that wasn't too bad. So describe the event X less than or equal to 2 in words. So we're going to do another text box. So you'll just write this out. Okay. So we're going to say in words, this is at most 2 non-word errors. That's what that means in words for that. Now, what is the probability? So we want probability that X is less than or equal to 2. So we're just going to combine all of these 0.3, 0.2, and 0.1, and we should get 0.6 for our answer on that. And then finally it says what is the probability X is less than 2? So probability X is just less than 2. Those are different. So that's everything less than that. So that it should be the 0.2 and the 0.1 combined, so 0.3. So that's how we're finding all of these. And that's just a very basic way of doing these random variable probabilities. I think we learned that during our probability unit last test before we started this one. So we should be pretty good on that. Now let's move on to the next section, which is finding the mean, or what we call the expected value, and then we're going to do standard deviation. But here we have a very interesting scenario that looks pretty complicated because there's a lot of numbers. I'm going to ask that you go ahead and grab your Inspire right now. I've already got mine set up on another screen, ready to go. So right here it says housing in San Jose. How do rented housing units differ from units occupied by their owners? Okay, here are the distributions of the number of rooms for owner-occupied units and renter-occupied units in San Jose, California. So this is the number of rooms in a house, and these are the probabilities that those rooms happened in houses that were owned, and the probability that those houses were rented. Okay, so you can almost imagine these same numbers are being represented twice here, and these are probabilities for each one. Now, it defines our random variable, and we always see that with these. So it says let X equal the number of rooms in a randomly selected owner-occupied unit. So I'm going to actually draw something here. I'm going to put an X for owned, right? Owner-occupied. And then Y is the number of rooms in a randomly chosen renter-occupied. So this is Y. And that's helpful to me for organizing this, okay? Okay. So first thing it says, it wants us to make a histogram suitable for comparing the probability distributions of X and Y, describing differences you observe. Now, say on a test, I'm not going to be asking you to like construct a histogram, but I want to go back through the process of how we would want to do this. And it's going to be a little different than what we're used to. So now you're going to take your Inspire and we're going to set it up. And I'm going to go ahead and pull this over to my main screen here. This is how we want to set this up. I would call this first list rooms. So we have our rooms here, which is this top row. Normally we would put X there, but because we have these separate probabilities, we're going to put it like this. So P of X and P of Y. So we want to go ahead, and I'm going to pause this video, and you're going to input this information right here into your calculator. And I want to show you how. I'm going to save this real quick. I'm going to show you how I did that. So put P of X for this second column, P of Y. So these are the probabilities for each of those random variables. And so I'm going to go ahead and pause the video, and you're going to input these into your calculator. All right, so you should have these input. It should go all the way to 10. And you have all these different probabilities. So let's talk about how you're going to make this histogram. Now, normally what you would do, and don't do this, is you would add a page, data and stats, and you would have to, you do something here, right? So rooms, and we never use the Y column, but if I just put rooms, it doesn't work. If I put this, it does something that I'm not used to. So we're going to do this a different way. We're actually going to do this the way that we did it in our second chapter, and it almost is like a bar graph, but it is actually going to be a histogram in this case, but it's going to look like a bar graph. That's okay. So what I need everybody to do, once you have this in, you're going to press Menu, Data, and go to Summary Plot for this one. Now, we want our X list to be rooms, okay, because that is this top list. That's the numbers we want. Our summary list is going to be the probability. So we know that this is going to be the ones that are owned. Probabilities of X. Now we want to make a new page. Hit OK. There's our histogram for this is rooms that are owned. So we're going to go back. You can use your scroll pad here, go back, or hit Control to the left. we're going to repeat that for the y. So we hit menu, data, summary plot. This is rooms, and this is y, new page. Hit OK. Okay, so if you go back and forth between these, we have a comparison. And we can see that the rooms that are owned are more symmetric. They have higher frequency of more rooms for those that are owned. That's a lot of rooms, by the way. My house only has 3, and I own mine, so it's kind of strange to me. But then we have rented here, and you can see it's skewed to the right. Okay. So in the problem, it says to describe any differences you observe, and we're seeing we're seeing the symmetric versus skewed distributions here. Now what it wants us to do is it wants us to find the means. So how do we find the means of these distributions? Well, we could eyeball it by saying, okay, where's the center? Well, it looks to be about here on these. If I go back, it's about here on this one. Maybe shift it up just a little bit, because we said the mean is always a little bit on the skewed side. If it's a skewed distribution, it means to the right of that median. But we have a way to do this very quickly on the calculator. Now, obviously, we have this. Let me go to our notes here. We had this. Where's the formula? We had this formula here: multiply each possible value by its probability, and then add the products up. We could do that, and it would work. But obviously, we have a calculator here that can help us. So we're going to go over. So you should go back. If you can click back to your spreadsheet, go over, and let's find the mean of the probability distribution for x. So we're going to put menu. We want 4, 1, 1. Oops. 4, 1, and then we want one variable statistics. Hit OK. So on this one, we had to change 2 things. First off, we want rooms as our x list. Frequency list is going to be these probabilities. So we want P of x as our frequency list. Hit OK. Okay. So we're seeing that the mean is 6.28. Okay, that's what our mean is. So we're going to go back to our PowerPoint here, and we're going to write that down. So I'm going to say mu. Let me write mu of random variable x is equal to 6.28. So the mean number of rooms for both types. So that is for the owned. Then we want mu of y. So we're going to go back. We need to go to another blank space here. Menu 411. This time we're going to do it for rented. Hit OK. 4.18. I'll round that up to 19. 4.19. And these values should make sense based on what we saw with our history. 4.19 makes sense here. Should be about there on that center. Go to this one. 6.28. Seems good. Yeah, that should be about right on that center there, right? Okay, perfect. So that's how we're finding mean and standard deviations. You had different examples that we looked at in our notes. If you want to go back and remember those, yeah, absolutely, you can do that. We did, I don't know what all examples we did initially, but I think we did this APGAR score to find its mean and standard deviation of it. So we did do some practice problems there. We have not found standard deviation yet, so let's do that. That's going to be this third part here. So find and interpret the standard deviations. We're always going to be using sigma for this. So sigma of x, sigma of y. It was funny, there was somebody that had trouble drawing sigma. It made me laugh. It's a circle, and then you put the little, I mean, that's good enough, right? It's not to be perfect. So no stress on whoever that was that was having trouble with drawing that. Now our standard deviation normally would be s of x, but we notice our standard deviation is going to be down here. So we're going to do round it to 2 places. 1.64 for the owners. Okay. And this again is the spread. Remember, that's what this measures. 1.31 for the renters. So it's more consistent. That's basically what that's telling us. It's more consistent. Renters are more consistent to the values that they are, right? Besides the fact that it's skewed, they are typically less spread out and more consistent around their mean. Okay. All right, so that's mean, how to calculate and interpret mean standard deviation of a random variable. Now we're going into transformations. We've got two more problems. So right now, what that helped you with was these first three. Now we're going to these next two over here. So let's go ahead and let's look at that. So we're talking about transforming a random variable by adding or subtracting a constant and multiplying or dividing by a constant. Okay, so we had all these rules that that we used right here. So linear transformations, that's what we're doing. What happened when we added or subtracted a constant? Well, it changed the center and location, but it didn't change the shape or spread. So addition only changes the mean. Addition and subtraction only changes means. However, multiplying or dividing multiplies or divides the center, everything basically. It just doesn't change the shape. Okay, and that was one of the last worksheets that you guys had before we went on to break. So that's the idea, is remembering these rules of what changes when you multiply and what changes when you add or subtract, right? Okay, you're adding to the mean only when we do a linear transformation of addition or subtraction, and then multiplying it changes everything. Okay, so let's look at this. It says describe the effects. It says a small ferry runs every half hour from one side of a large river to the other. The number of cars X on a randomly chosen ferry that has the probability distribution shown below. The mean and the standard deviation are given to us right here. Okay, so it says the cost for the ferry trip is $5. Make a graph of the probability distribution for the random variable m equals money collected. So let's talk about how we could graph this if we wanted to. I'd like everybody to make a new document. I know we just did a ton of work there, so if you want to save that, that's fine. I'm going to make a new document. We're going to call this cars and then probability of cars. Okay, you could call it X and P of X if you want, but I'm going to list all these out. 1, 2, 3, 4, 5. So that's the different amount of cars that you could find on there. And then we want the probability for each car. So we say 0.02, 0.05. Let me go to the other side now. We want 0.08, 0.16, 0.27, and 0.42. So those are all of our probabilities. Now, we are interested in the amount of money they make. So money. How much money they're making? Well, it's going to be the number of cars times 5. So I'm going to put an equal sign in this little gray area here. So hit equals. Money is equal to cars times 5. So it's going to take that first column over here and multiply it by 5, which is what we want. So there's the new distribution. Now, how do we graph that? Well, we're going to do the same thing we just did with the other graph, which is we're going to hit menu, data, summary plot. Cars is our X list, but we want the actually X list is money. Probabilities are going to be the same, so we're going to hit OK. And this is somewhat what our histogram is looking like. Histograms are supposed to have no spaces in between them, but this is just going to give us the idea of what we get. This is more of a bar chart than a histogram, but that's okay. It's obviously skewed to the left. We would normally want to put this side by side for it to be a histogram, but at least we're getting a general shape of what it looks like. So let's go back to this. Describe its shape. Well, it's skewed to the left, and we could actually tell that just by looking at these probabilities that it was going to be skewed to the left. Okay. Now we want to find and interpret the mean and the standard deviation of this distribution. Now we talked about this is multiplying, right? It's $5 per car. So it's multiplication. We're multiplying by $5. So what do we need to change here? Well, we're going to take the original standard deviation, or excuse me, original mean. We're going to multiply it by 5. So the mean of M is equal to 3.87 times 5. So let's see what that is. 3 times 5, 19.35. Okay. Then for multiplying, we do the same thing. We're going to take this and we're going to multiply it by 5. So sigma of M is equal to 1.29 times 5. Let's see, we get 1.29 times 5, 6.45. There we go. All right, so we got that value, and that is that's how we're supposed to do these transformations. If it were just addition, we would just change the mean. If it were subtraction, we'd just change the mean. If we were dividing, we would change both of them. Okay, so that should be something that's familiar from previous chapters. So you have a problem like that with transformations. Talking about skee ball here. So just you're going to have to figure out what is the transformation on here, and make the calculations. Okay. Now the last one, which is what I would consider probably the most involved on here. Now we're combining. So it says find the mean and standard deviation of the sum or difference of independent random variables. So we're actually combining variables together. Okay. Combining these together, and I think of the problems that you have, this is one of the most difficult ones on this whole problem set. You're still doing these word errors, and it shows these distributions, so you'll need to look at that one and try to figure that one out. But we're going to talk about a large auto dealership. They're keeping track of sales and lease agreements. So you either sell a car or you can lease it, which is basically kind of like renting. And they're made each hour of the day, and it says let X equal the number of cars sold and Y equals the number of cars leased during the first hour of business on a randomly selected Friday. Based on previous records, the probability distributions of X and Y are as follows. So it says this is X, this is Y, and this is each hour of the day, leasing and such. So T is defined as X plus Y. It says assume that X and Y are independent. So in our notes that we did, we talked about combining random variables. We have a lot of different formulas that we're going to be talking about as we review this. But one of the main things for random variables is the only way to determine the probability for any value of T is if they are independent. We can't have one outcome influence the other outcome. They need to be independent of one another. Okay. So now that we know that in this problem, we're going to be able to find this. So we want to combine them. We want to find the combined means. So we have the means here. They already calculate them for us. So how do we find the new mean? Well, we're going to go reference our formula here. So for any two random variables, X and Y, the expected value of T is going to be adding those two means together. That's a pretty simple formula. So we know that this is going to be equal to mu of X plus mu of Y. So that's going to be 1.1 plus 0.7, which is going to be 1.8. So that's not too complicated of a formula to follow there. So this shouldn't be too bad. Okay. Now we're going to continue with the same set of data, but now we want to find the new standard deviation. So we need that formula. How do we find standard deviation? Okay. So I've got the formula here. So we're going to take the standard deviation is equal to the square root of each standard deviation squared. Okay. Now this is the summation of the variances squared. So we have to make sure that that we write it up that way. So I'm going to write it like this. we need our standard deviation. So we're going to say sigma of t is equal to, we're going to put a square root. We want to take sigma of x. I better write this. Sigma of x. We need to square that. Add that to sigma of y. We're going to square that. So now let's rewrite this with the numbers, and then we'll use our calculator. So we have 0.943. I'm going to put it in parentheses. We're going to square it. Then we're going to add that to 0.64. We're going to square that. My wife just got home. She got the alarm going. Okay, so now let's square that. So it's 0.943. We're going to square that. Plus 0.64. Square that. Let me make sure I've got that right. Looks good to me. Let's submit it. So we get 1 point, and I'll round that up to, we'll go to 1.14 is the new standard deviation of these combined variables together. So he can expect, on average, he's going to sell lease combined 1.8 cars. And we're expecting that to vary by 1.14 cars. Okay. Now it says the dealership's manager receives a bonus for each car sold, and a $500 bonus for each car sold, and a $300 bonus for each car leased. Find the mean standard deviation of the total bonus B to show your work. So we have a transformation that we just did transformation. So we have a transformation occurring for each of these. So what we would need to do is we need to do the appropriate transformation for each. So for instance, we know that this one down here is going to be or this one up here, each time he sells it, is going to be times $500, right? It's a multiplier. So multiplication also affects standard deviation. For leased, it's going to be times 300. For standard deviation, it's times 300. Okay, so we're going to do these transformations, and we need to do this combination. So I need to do the transformations and then add those together to get the mean. So let's go to the next slide. So to find the mean of, and we call this bonus B. So the mean of B is going to equal, well, we want 500 times that 1.1 expected cars that we sell. And we're going to add that to that 300 times 0.7 leased. Okay, we need to know what that is. So let's do that. 500 times 1.1 plus 300 times 0.7. So 760 is what we should get for this. So we're going to write that down. So you can expect a $760 bonus on a Friday. That's pretty good, right? What about the standard deviation? Well, we're going to have to do the same thing like we did on part 2 here, except these values need to be multiplied by 500. So it's not that different than what we did. Or this one's 500, this one's 300. So I'm going to rewrite this as 500 times 1.1. We're squaring it. Plus, we want 300 times 0.7. We're squaring that as well. So let's see what we get from that. I'm going to just go back up and copy this. Let's do 500 times that, and then 300 times that. All right. So 509. Now we wouldn't just multiply this value up here by something. We actually have to do these transformations. Okay. So that's our number right there. 509 point, and I'll just say 0.1. That's fine with me. So 501.1. That's a pretty big I have that wrong. 509.1. That's a pretty big standard deviation if you're talking about your money, how much it can vary. So you can get, I mean, it could be higher than 670. Like a lot higher, or it could be a lot lower. So that's that variation there. But this should be the right work for this, and that's really the main review that we wanted to get to. This 30-minute video. Make sure that you rewatch it if you need a little help with looking at that. You have notes that we wrote for all of these rules here for combining random variables if you need those to work on this sheet. If you have specific questions you want to ask me, send me an email and I will get back to you on those. Okay. Do expect a new lesson tomorrow or the following day. As we're going to continue, we're going to be talking about binomial and geometric random variables. That's all for this lesson.